Hello everyone, welcome back to my YouTube channel. In this video, I want to explain how to solve past paper from EJU Mathematics 2022, second session, course 2, the first question from first section. So basically, this is the first question from this past paper. Before I start, I want to say thank you to one of my subscribers who sent this past paper to me. I really appreciate it. Okay, if you want to watch the solution from the other problem on this paper, you can check link on the description box below. You can also check my EJU playlist if you want to find another solution for your EJU preparation. Don't forget to hit the like button if you like my video. You can also share this video to your friend. And don't forget to subscribe my YouTube channel. Okay, let's start to solve this question. In this question, we have a quadratic function y equals to ax squared plus bx plus c, where a is not equals to 0. The graph c of this function intersects the straight line y equals to 1 at 2 points such that the distance between the 2 points is 4. And furthermore, it intersects the straight line y equals to 3 at 2 points such that the distance between 2 points is 6. Let the coordinate of the vertex of C be P, Q. So this is the coordinate of the vertex. When we take one of the point of intersection of C and the straight line y equals to 1, and denote its x coordinate by alpha, we see that modulus alpha minus p equals to blah blah blah. So, I will give you an illustration to solve this question. Assume I have a parabolic quadratic function. If you draw it, you will obtain a parabola, something like this. I do not know the position of the parabola, and I do not know the parabola is whether open upward like this or open downward. But it don't make any difference. So in this illustration, I will assume that the parabola is open upward like this, and then I will assume this is my y-axis, and then this is my x-axis, and then this is P, and then the y coordinate of the vertex is Q. So I assume like this. And also, I will draw a straight line y equals to 1. I will assume, once again, this is just my assumption, I will assume y equals to 1 is here. This is y equals to 1. And then, the x coordinate where the curve intersect with y equals to 1, we denote it by alpha. So, this is alpha. Of course, you can also say that this is alpha. Once again, no matter which coordinate you take, I think at the end, it won't make any difference. So, up to you. I will assume in my illustration, I will take this is as alpha. Okay, from this illustration, we know that since the distance between 2 points is 4, the distance between these 2 points is equals to 4, and the vertex is here, so P minus alpha should be equals to 2. Alpha minus P or P minus alpha, once again, it won't make any difference. So you can see on my illustration, alpha minus P, the modulus of alpha minus P must be equals to 2. Because the distance between these 2 points is equals to 4, and the vertex is always at the middle. So my answer for alpha minus P, or the modulus of alpha minus P, is equals to 2. Hence, When the coordinates alpha, 1, I will take alpha, 1 here, yeah? So this is 1. The coordinate alpha, 1 of the intersection are substituted in the quadratic function 1. So I will substitute alpha, 1 to this quadratic function. Then function 1 can be expressed using a, p, and q by blah blah blah. So my goal here is I want to express my quadratic function in terms of a, p, and q. How to express it? First of all, we just need to substitute these coordinates into the quadratic function. So I will substitute alpha, 1 into my quadratic function here. Y is equals to 1 and then x is equals to alpha. So I will get 1 equals to a alpha squared plus b alpha plus c. We need to express this in terms of a, p, and q. So I need to get rid b, I need to get rid alpha as well, and also I need to get rid c. Oops, sorry. Okay. Since I need to get rid alpha, b, and c, I need one more equation, I think. So my second equation is I will substitute this vertex into the quadratic function. Then I will get q equals to a p squared plus bp plus c. And then I will subtract it. Then I will get 1 minus q equals to a alpha squared minus a p squared. You can vectorize a, so you will get a open bracket alpha squared minus p squared close bracket, alpha squared minus p squared. Do the same thing for this expression. You can factorize b, then you will get b open bracket alpha minus p. Of course, the c has cancelled out. Alpha minus p, if you see from this illustration, alpha minus p is equals to negative 2. You need to be consistent, yeah? Alpha is smaller than p, that means alpha minus p is equals to negative 2. So I can change alpha minus p here by negative 2, and for this expression you can factorize it first. So 1 minus q is equals to a alpha minus b alpha plus p plus b times negative 2. Of course, this alpha minus p can also be substituted by negative 2. Then I will have 1 minus q equals to a times negative 2 times alpha plus p minus 2b. If you see my equation here, I just need to get rid the alpha. I already get p here, I already get q and a, but I need to get rid alpha. How to get rid alpha here? Of course, I can use the fact that alpha minus p is equals to negative 2. Since alpha minus p is equals to negative 2, then alpha is equals to p minus 2. If I substitute it into here, I already get rid the alpha, and we need to get rid b as well, because there is no b here. How to get rid b? If you see once again from this illustration, p is our x coordinate of the vertex. As you know, if you have a quadratic equation and you want to find the x coordinate of the vertex, we can use formula x symmetry is equals to negative b over 2a. The x coordinate of the vertex is p, so I have p equals to negative b over 2a, then b is equals to negative 2ab. So now I will substitute alpha by p minus 2, and I will substitute b by negative 2ab. Then I think I will get the final answer. So 1 minus q equals to a times negative 2. I have negative 2a times alpha. Alpha is p minus 2. P minus 2 plus p minus 2 times b. Negative 2 times negative 2ab, we have plus 4ab. You can simplify it. 1 minus q is equals to p plus p is 2p. 2p times negative 2a, you have negative 2ab. Negative 2a times negative 2, you will get plus 4a. And then plus 4ab. Negative 2ab, oops, sorry. This is negative 4ab, yeah? Not negative 2ab here, because negative 2a times 2p. We have negative 4ab instead of 2. You can cancel out negative 4ab and plus 4ab. Then you will get 1 minus q equals to 4a. We can rearrange this into 4a plus q equals to 1. This is the answer for letter B and letter C. So B equals to 4 and C is equals to 1. We already get B, which is 4, and C, which is 1. Okay, next, similarly, by considering the point of intersection C and the straight line y equals to 3, we have the equation blah blah blah. Now you can use the same method, but you need to consider y equals to 3. The question already tells us that when the straight line y equals to 3 intersect with the graph, the distance between 2 points is 6. So if I assume this is y equals to 3, that means, that means the distance between the point of intersection and the x coordinate of vertex is equals to 3, because the distance between 2 points is 6. You can use the same method, yeah? So if I assume this coordinate as, let's say, beta, so beta minus p is equals to 3. I will write down here, I think. Beta minus p is equals to 3. And then we can substitute beta, comma 3, because the y coordinate here is 3. You can substitute beta, comma 3 into the equation and repeat the same process. Okay, if I substitute it, I will have 3 equals to a beta square plus b beta plus C. And then to express it in terms of A, B, and Q, we can use the same equation here. This is the equation when we substitute the vertex into the quadratic function. Q equals to AB squared plus BB plus C. And then once again you subtract these two equations, then you will get 3 minus Q equals to A beta squared minus P squared plus B beta minus P. Beta minus P is equals to negative 3. Beta is less than P, yeah? So beta minus P is equals to negative 3. I can substitute it into my equation. A times beta minus P times beta plus P plus B times negative 3. This beta minus P is also negative 3. I think I will substitute it directly into this equation. Then for beta plus P, you can use the fact that beta minus P is equals to negative 3. So beta is equals to P minus 3. And also for B here, you can use the fact that B equals to negative 2AB. So by using the same process, you will obtain 3 minus Q equals to negative 3A. Beta is P minus 3 plus P. I will directly write down here as 2P minus 3. 2P minus 3 plus B is negative 2AP, so negative 2AP times negative 3 from here, you will get 6AB. Finally, you will have 3 minus Q equals to negative 6AP plus 9A plus 6AP. Once again, we can cancel out negative 6AP and 6AP here. That means you will have 3 equals to 9A plus Q. So this is your answer for letter D and E. Your D is 9 and then your E is equals to 3. 9A plus Q equals to 3. Thus, from these two equations, we obtain that blah blah blah. Once you get these two equations, I think it is easy for you to find A and Q, because you have two equations with two unknown variables. So by using elimination, for A plus Q equals to 1 and 9A plus Q equals to 3, I will subtract it. I will have negative 5A equals to negative 2, then A is equals to 2 over 5. You obtain A here. So A equals to 2 over 5. And then for Q, just substitute A into one of these two equations. If I substitute it into the first equation, then I will obtain 4 times A, which is 2 over 5, plus Q is equals to 1. That means Q is equals to 1 minus 8 over 5. That means Q is equals to negative 3 over 5. This is your answer for Q. So H and I here is 3 and 5. Let's proceed to last question. Basically, this is the last question from the first question on this past paper. Furthermore, if C passes through the point 2, negative 1 over 5, and the x coordinate P of the vertex is less than 2, we obtain that B equals to blah 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 and C equals to blah blah blah. So now we want to find B and C. B is the coefficient of x, of our function. This is B, yeah? And C is the constant term of our function. Since I know that our graph or our function passes through the point 2, -1/5, of course I can substitute this into our function. Our function is y equals to ax squared plus bx plus c. Don't forget, you already know a is 2/5, yeah? So now our function is y equals to 2/5x plus bx plus c. I will substitute y with -1/5 and this is x squared, and x with 2, then I will obtain my first equation. -1/5 equals to 2/5 times x squared, 2 squared is equals to 4, plus bx, our x is 2, so 2b plus c. If you simplify it, you can move 8/5 to the left hand side. So you will obtain -1/5 minus 8/5. You obtain -9/5 equals to 2b plus c. So 2b plus c is equals to -9/5. Of course, we need one more equation because we want to find B and C. So we have two unknown variables. So at least we need one more equation. To find another equation, I think we can use this one. B equals to -2 times A times P. We already know A, but let me think, we do not know P, yeah? We still do not know P, but we know that alpha is equals to P minus 2. Wait a second, let me think. You know A, you know Q. So I think we need to find the symmetrical axis first. So let me use this equation. X symmetrical equals to -b/2a. So I think I will find the symmetrical axis first, which is -b/2a. Since I already know a, which is 2/5, so my symmetrical axis is equals to -b/2 times 2/5. Then my symmetrical axis is equals to -5b/4. If I substitute our symmetrical axis into the function, then the y coordinate is equals to q. We already know q. You need to remember, yeah, q is the y coordinate of the vertex. So if I substitute the x coordinate of the vertex, then I will obtain the y coordinate, which is -3/5. So if I substitute x symmetrical to this equation, y is equals to -3/5 equals to 2/5 times x squared, this is our x, -5b/4 squared plus b times -5b/4 plus c. think this is my second equation that I will use to find B and C. First thing first, I think we need to simplify this equation first. It's look a little bit messy, but we can simplify it, of course. 25/16 b squared times 2/5. 5 here, 8 here, so you will obtain 5/8 b squared. And then for this one, I got negative 5b squared over 4. I think I will directly substitute c by negative 9/5 minus 2b. From this equation, you can substitute c. C is negative 9/5 minus 2b. Okay. Let's simplify a little bit before we factorize it. As you can see here, we have quadratic function. So I think at the end we need to factorize it to find the value of b. I have 5/8 minus 5/4 here. 5/8 minus 5/4 is equals to 10/8. Negative 5/8 b squared. So negative 3/5 is equals to negative 5/8 b squared minus 9/5 minus 2b. I will move all the terms here to the left hand side, leaving the right hand side equals to 0. Then I will obtain 5/8 b squared plus 2b, and then negative 3/5 plus 9/5, you will get plus 6/5 equals to 0. By multiplying all the term by 40, I think I will get 5/8 times 40, you will get 25b squared plus 2 times 40, you will get 80b. 6/5 times 40, you will get 48 equals to 0. This is the last thing that we should do. We need to factorize the quadratic equation here. If you factorize it, I think 5. If it is too hard for you to factorize it, you can solve it by using either quadratic formula, or you can solve it by using by converting it into completing square form. But I think we can factorize it. For 12, negative 12, negative 4, plus, I think, plus 12 plus 4. That means my first possibility for b is negative 12/5, and then my second answer is negative 4/5. If you see here, the format of b is j/k, so I think the correct answer is this one. Of course, you can check, yeah. I think this is the condition that we can use to decide which b we use. But since we already know the format, to save a little bit time, I think my final answer for b is negative 4/5. So this is my answer for b. Once you get b, I think it is easy to find c. 2b plus c equals to negative 9/5. So 2 times negative 4/5 plus c is equals to negative 9/5. So c is equals to negative 9/5 plus 8/5 then C is equals to negative 1 over 5. This is our L and M. L is 1 and 5, M is 5. Okay, that's it for this video. In my opinion, this is quite difficult question, but I really hope you can get my explanation. I hope I can see you guys on my next video. Thank you and bye-bye.